Hello, and welcome back to Poor Man's Electronics Bench. In this episode, I will be working on the restoration of a Sencore model RC121 Resistor, Capacitor, and Diode substitution box named the Substitutor. This device can aid a technician in either quickly and temporarily substituting a known value component into a circuit on another device that is suspect, or to use to conveniently vary a value on a new circuit design to test and adjust the circuit's functionality. This device was in fair condition when purchased on auction, and I will go over what I have found on it that are issues that need to be fixed in order to restore it to its functionality. The electrolytic capacitors needing to be replaced will require the restuffing of the original electrolytic capacitor Dynamite Stick type arrays, and other resistors, capacitors, and switches will be replaced to bring it back to its installed components tolerances and make it a good working unit again. I hope you enjoy the video and the information. Hello again, and welcome back to Poor Man's Electronics Bench. In this episode, I am going to be working on the repair and restoration of a Sencore model RC121 resistance, capacitance, and diode substitution box. This particular model is marked RC121 as well. This looks like an older version of it. There's a newer version that has a collapsible handle instead of the rigid metal handle that's installed on this one. And I am going to disclose that I am guilty of doing some work on this item in order to expedite some things going on just to get it back to working condition again, and good cosmetic condition as well. I ended up looking at this top handle here. It's got a painted Sencore logo on it. I don't know if it's brushed steel, brushed chrome. I don't think it's stainless because it wouldn't have corroded if it was stainless, at least probably not to this extent. But I was able to take, up to now, I was able to take some Scotch-Brite, some green Scotch-Brite, and work it carefully on the areas around the lettering and actually on top of the lettering, and it did not remove the paint, and it seems to be a pretty good way of restoring that part for now. I'm going to continue that for the restoration part of it. The rest of the cabinet is basically a wrinkle black paint that's got stamped in feet. I might try to figure out how to put some rubber molded feet on top of that just to keep the paint from getting damaged further. The rest of the cabinet is in pretty good shape. It's got some screw holes on the back. I'll go over that in a minute. And the top has got some dust on it. I'm going to do my best to clean this up, and then if I can get it cleaned up to a good extent, probably spray it with some satin clear to even out the color and texture of the wrinkle black paint. I've already taken the hardware off the front, and if you notice, it's already had some work done to it. I'll go put this aside just for 1 second. The original Goodman electrolytic capacitors that were in here, unfortunately, chose to evacuate their electrolyte on the things and cause some corrosion on this metal mounting bracket. This looks like it had some sort of plating to it, but the electrolyte didn't care and just ate through it. So I'm going to have to clean that up as part of the process and scrub out the inside of the box here, probably spray paint it with something as well to preserve as much as I can out of it. But it's in pretty good shape cosmetically. I can't really, as far as cosmetics go in a cabinet, I can't really complain about it. It'll get some new hardware mounting screws on things because nothing matched out of the original purchase. So we'll put the cabinet part aside for now, and we'll go over the inner workings of said device. This is the resistor network here. It has two different stacks of rotary switches which go to two different connections on that slider. One is 1 watt for the ×1, and for the higher value resistors in the ×1000 range, it's only a 1/2 watt. I ended up getting some little bit higher wattage replacements, but I found that most of the values on the resistance deck are about the same, or are within tolerance actually. They're all Ellen Bradley style resistors and look to be, they've got something on them. I'll have to clean those off a little better. I don't know if it's some sort of residue from the electrolyte vapors or something. I ended up cleaning up all of these switch decks as well as I can. These particular ones are, they're not sealed per se, but they're covered up to the point where you can't get direct access to them well, so I had to, I'm guilty of flooding them with some regular contact cleaner and then putting some D5 on them and working it in as well. The first capacitor, there's a switch that has the smaller value capacitors here and also two rectifiers, a selenium and silicon rectifier. I checked the functionality out of all of those and I found those to be pretty close to within tolerance, so I'm not, and the leakage actually wasn't too bad on them, so I'm actually not going to replace any of those. It was kind of surprising. This has there's a rectangular looking guide on there that is a capacitor array that has the capacitors in a picofarad range, whatever you want to call it, and it's all functional. The leakage is very low on them, and the thing is, they're very low hours. Are they old capacitors? Yes. If they were going to remain in the circuit, I definitely consider replacing them if it was something that I cared about not exploding while I wasn't monitoring it directly. Also, there are some higher wattage resistors. There is a network that has an ohm switch for 20 watt resistors in two different ranges, and that is connected to these resistor arrays as well. I don't know if you'd join a description of them and call these sand dome resistors instead of can dome or sand resistors, but they are apparently working well. They've got some insulated cardboard between them. I'm not really going to take things apart to try and get the branding on there. All I can see is can't see the one word Milwaukee sticking out underneath the cardboard there, which is a little interesting. So I'm not sure where these are made or what time period they were made, but they seem to be all functional, so I'm going to leave those alone. And the things I found that needed to be addressed on this item were, there are two slide switches that control the R1 to R1000 ranges on both resistor arrays. These switches are quite intermittent. I tried cleaning them up as well as I can, and they were still intermittent, and I tried to get the covers open a little bit without trying to dismount the switches, and I wasn't having any value or success. I did a little research and found out that there's practically direct replacements available for those particular slide switches still. So I am going to just forego doing any more work on them and drill those rivets out and replace them directly and put some hardware in there. And then the fourth section of this, which is the electrolytic capacitor section, is the one that is going to give the most grief as far as the repairs. These are all microfarad range capacitors, and I found that they were all just either well out of tolerance or not reading anything at all. They were all connected through three existing Dynamite Sticks to one switch here, and it's a very interesting switch. I was able to clean and lubricate the switch very well. This switch has some complexities as far as challenges for using replacement capacitors, and what I've found is I'm best going just with the direct values and restuffing the capacitors that are inside of them. On careful examination, since there's really no schematic available for this particular unit, it's hard to get the lighting well, but there is another paralleled switch deck inside of this one that's exposed on top. And if you look carefully, there's a switch position here. You'll see two contact points. What this does is it joins two contact points on this deck, but underneath there is another contact point that is indexed that is connected to a contact on the other side of this phenolic resin board that has another one of these contacts, but the rivet goes through and holds that contact into place. And what that does is, for the lower values on this range, it starts indexing and paralleling another value to it as the switch is turned. You can maybe see in this one position here, I can show it to you. It's a tricky little assembly, but it gave some engineering flexibility. Could maybe see it right on that one vertical contact. You can see a little piece of metal sticking up on the inside where it's not covered by the rotor on this deck. You can see it move. So that parallels actually three values of capacitors together in order to get the maximum values. And you have two connections to plug in test leads to. One of them is called the A range and the other one is the B range. So the B range is going to be a higher range, and it uses the combination of the two DEX connections to join and parallel capacitor values in order to get you the indicated range off the panel. It seems like I'd just be able to... I marked my capacitor values and my leads for arrays very well as I disassembled everything. I had one ground wire that broke off, but I know where it goes through. That's a common ground. So that's going to be able to be restored, restuffed. And what happened was I just decided to cut open the existing capacitor. I think they were Goodman branded. I'm not entirely sure. They look very familiar to to two other ones I had in another Sencore box. But here's what I did: is there was 3 containers for the arrays. The values were kind of not doing very well on some of the tubes. What I decided to do is try to reuse these tubes, since it just made sense. They were already made, already had the bottoms to all of them. I was able to clean out most of the contents and electrolyte on the inside. I'll probably end up coating this with something before I restuff them and reseal everything. So these are the 3 tubes I'm going to restuff, and I'm not going to go into restuffing details because I covered that on my other substitution box, capacitor sub box. But here is one of the capacitors of the same vintage that I took out of that other Sencore ES102 box. This is a Goodman. This has 4 components in it, and just I'm going to crack that one open, but before I do, I'm also going to give you a view of what was in those other 3. This was the mess I pulled out of them. These things were totally dry. All the electrolyte was crystallized, and they were basically junk. I ended up just gladly pulling them out, and they didn't, surprisingly, it didn't come out too bad. The only thing I did is, like I said, I made a vertical cut in the cardboard tube itself on the back side, away from the values, and I am going to cover doing the same thing with one of these other Goodmans. Now, back when I restarted the ES102 box, I kind of mockingly laughed at restuffing these, but looking back now, for one, I kind of need to in order to expedite things on the build and restoration of this unit. And it wasn't really that bad of a thing to do. Now with that ES102, the existing switch was similar to that one, where it bridged contacts together in order to create values. That original switch was destroyed, and there was no way I was going to get a replacement for it. So it ends up that I chose to go the route of creating capacitor values that would match what was on the cover for individual switch contacts on the new switch. So here's how I cracked one of these guys open for restuffing here. I basically just took a look and saw where the writing was on my capacitor, and I want to try to arrange it so I am going to cut open the back side of it only. I'm going to presume that these are fairly close to configuration of the other ones, and you can feel the different textures of stuff you're cutting through as you're cutting into it. This top is kind of like some sort of resin or glue plug. Once you get past that, you are going to be cutting into the aluminum foil for the electrolyte. And then at the bottom, got a little bit of a base material. And just grab something small to pry with. I started at the top here, and these things fairly readily fall apart. They're not, I can't say this is going to happen like this for every brand capacitor out of these older ones, but this one is not really wanting to give a battle as far as coming apart. There's no heat involved, but there is all sorts of stuff. I'm wearing gloves because I should. I just don't know much about this electrolyte. I know it's semi-corrosive. I know it's not. I don't know if it's guessing it's an alkali, but I'm gonna try to loosen this up as all as possible here. Seems like the whole bottom part is already wanting to come off. So there we go. The object is just to try to save it as in an intact form as possible. Ooh, well, I split the cardboard open. I'm not going to be reusing this one per se right now, so it might come into play in something else, but whoops. Sorry about the camera shake there. Had to hit one sticky spot here. Don't want this to... The other ones came apart a lot easier. But just by going along the top here, there's some sort of resin. I'm not sure exactly what was going on up there, but... And there is all sorts of stuff that comes apart and comes out of here. The bottom is just a cardboard plug. And by whacking and smacking the cardboard itself a little bit, if I found any areas that had stuff stuck to it, like up here, let's say, I just take the screwdriver and smack it around a little bit, and those pieces just seem to come loose fairly readily, so without disturbing the appearance of what's going on too much. So like I said, this one's pretty sacrificial. It's just going to be taken apart for the sake of taking it apart. That top, whatever type of resin or plastic or it is, you can wiggle it. And the other ones are kind of pulled out easier. I'm going to probably give it a little assistance here. The one conductor that didn't seem to want to pull out very easily was the black for the common ground, so that one I just took a pair of cutters and cut that. I'm not going to try to be resaving this plug. I'm going to manufacture some new top plugs the way I did for that ES102 box with just using some plexiglass. These things, it's not worth trying to get a good solder connection to them. If you wanted to save the wires just for originality, you can do that. That's what I'm going to do in the RC121. And just to reclaim these wires here, I've got a very small pair of channel lock slip joint pliers. These come in very handy for items. And I was just taking it and crushing the resin until it gave up the conductors. Or you can just cut them, because odds are there's going to be some resin and corrosion within the top part of this wire. But if you wanted to reclaim as much wire as possible, this is about the easiest way to take it apart without too much effort and not needing any power tools. So I can get down all 4 wires here. So I might actually repeat the process on those other 2 tubes, and I can always reuse them for something. And then to restore them back to their contents, I can probably get as good a glue seam as possible back on this, and seeing that it's on the back side, it won't be very visible at all, and at first glance it's going to look like an original component, so it'll show some effort to restoration. So I could have done this and saved myself a bunch of work on the ES102, but I did go through a process where basically I created that process for what if I don't have a dynamite stick at all, but I want to create one. So this is option number 2 for gutting them. It's can work out, and it will for this device. And I will go into the repair of replacing some items inside the panel on the next part. So stay tuned. This content is available on YouTube and Odyssey.com. If you enjoyed this, please like and subscribe. Hope you return soon.